Hi guys, we continue solving our task here to do. So we should design the data structure that follows the constraints of the least recently used LRU cache. So least recently used, it's actually the value that is currently least recently used, so we don't remove it. So we have to implement this class of LRU cache where we have some capacity, and also we have key to get value by key, and also to put value by key. And here it's important that we have capacity, so we should initialize our LRU cache with positive integer size, and also we need to get by key and return the value, and if it doesn't exist, we return -1. And also we have a put method where we put our elements and we update the value of the key if the key exists. Otherwise, we update the value, right? So we should update, and otherwise add the key value paired to the cache. If the number of key exceeds the capacity, evict the least recently used key, and the functions get and put must execute in constant time. So yeah, so let's actually understand. So we actually need to design this cache from here. So let's write some test cases actually. So for example, we can so let's say that we have, for example, cache size of 3. Then we put, for example, 1 with 3. Then we put 2 with 1. And then we put 3 with 8. So currently, like all our cache is populated, but then we need to put 4 with 9. So when we put 4 with 9, it means we should remove the least recently used LRU, and in our case it's 1 because it's like least recently used element. So so what does it mean? So it means that the put and get operation should run in constant time. So it means that we need to have a map of key that corresponds to some node. Why I need to correspond to same node? Because at the beginning I should have like one key with some value, right? That have a pointer to some node. So here it's 1, and value would be here a pair. It would be a node with value and also previous and next. So previous in this case is null, and next also is null. Then I think that we need to have a tail. So tail, it would be we can have tail as a key here, but key is not actually it's not always a good point. So it's a good point to have this tail. Yeah, it's a good point to have a tail as a node, and also I think we need to have head also as a node. So when we put, for example, 1, we create this node and we put here head and tail as a 1. Then when we put 2, we also create a node here, right? And what does it mean? So we already have our tail that corresponds to this node. So it means that we can update here head, and we create this head node with 2 with value 1, and previous becomes prev head, and next would be null, and we update head to node 2 now. So tail is now node 1 and head is now node 2. And also we should update prev head next. It's equal to this new node that we created. So we do something like this. But in case of when we put 4, we also create like new node. We update our previous head as well. Then we update head, but here we need like to remove tail node and update tail node. So we have this actually operations on remove. So what we have here, so we need actually a map tail and head node. So let's define this. So first we need size. We need to understand what will be the size of our node. So it's capacity. So we also can just update to size. Then we actually need a node tail. Then we need node head. So we have size, tail, head. Then we need a map of integer. So it will our key and node. It will be our hash map where we will store all our elements. So let's create a class. We will call it node, and in this class we will have value. Then we will have node previous and node next. Yeah, so we have kind of this elements here. Yeah, and that's it. So when we create our node, we actually initialize our size. Here we check if map contains key. So if it not contains, we just return -1. Otherwise, we just return map get key, so and value from here. So it's very simple, get, and also like when we have result here, we need to remove our current node. So we get current node. We need to remove it, and then we should put it back with key and value, and map get key. Here it would be value, and then we should return map. Yeah, we should actually return this thing. So we see that we need actually to implement remove function and the put function. So let's first implement a private void remove, where we have a node. So how it will work? So first we need to take node previous. So it will be node prev. Then we should take node next. So it will be node next. And here, if previous is not equal to null, we should do like previous next equal to next. Yes, and if next is not equal to null, we should do next previous equal to previous. And in this case, we actually remove our current node. Yep. Then input operation, we should first do the following. So we are checking the size. So if size, if map size is equal to our size, it means that we should remove, yes. What does it mean? We should remove our tail. We should remove our tail. So here in remove operations, for example, we have node, right? And we have previous equal to null. So we not doing this one. But then if next is not equal to null, we still initialize with null. So current remove function should work here. So it means here, if it's equal to size, we remove tail. Yes, we remove tail. And then what we should do, yes, we should check if tail equal to null and head equal to null. It means here we create a new node. So it would be node, new node with value, new node with value. So that's why we need here to have constructor. So let's just create a simple constructor here. Okay, and we create actually this new node. Then we check if tail is equal to null, then tail is equal to new node, and head equal to new node. Yes. Yes. Then else if so what it can be? Can it be situation when, for example, head can be equal to null? So in this case, when we remove, we have prev and next. So prev next would be equal to null, and this one would be also equal to null. And also we should check if node equal to tail and node equal to head, then we should do like tail equal to null and head equal to null, right? Yeah, we should do this one. We should do this one. and this node. So it means that we have only one node, and we want to actually remove this one node. Also, it means that we want to remove it from map. So map remove remove key. So we have also key here, right? So we have key, so remove key. Yeah. We have remove operation. Then we put, we create a new node. So if it's equal, then we just do this one. Else, and here we always do like map put a key to new node. We also do this way. So it's remove tail. But actually, should we do this way? I think else. So for example, when we don't have enough of size, we just should create actually our new node and here input. I think here we should check if tail equal to null. Yeah, we should check this one like a separate function call. Here we should remove tail, and here we should just always actually add these two values. I think we don't need this one, so we do map put operation. Okay. Else, here what we should do, we should update our head, so as we described here. So update previous head, yes. Update previous head, next new node, but actually we should do it always. We should do it always, but here remove tail node and update tail node. So we remove tail. So first of all, we should take our tail. So it would be a next tail, tail next. Then we remove tail. So so we have tail node, right? We take here, it would be null. Here it will be next element. Node equal to tail null. So previous null and next So node next. Yes, next previous would be equal to null, and we remove from the map, and here we take this tail, next tail, right? And we update tail equal to next tail. Then we have tail and head. Then what we need to do, we should update our head. So we are taken we are taken a node and new node. New node previous should be equal to head. Then head next should be equal to new node, and head should be equal to new node now. And we put in our map. So something like this. Yeah, so we implemented, but let's try to run it. Yeah, so here we have contains. Then here we have remove tail, and okay. Yeah, so I suggest to have in the node also key. So we also have here key, and we need to put it here. This key equals to k, and then when we create new node, we have our key and value. And also in remove operation, we can take node key. And then here we don't need key. Right, so we have null pointer, cannot read field value because is null. Let's check. So here we have map. So we have put, right? Put operation for key. And okay, let me check. So first so what we should do, so it's removed from map. So first we should take like node, current node. Then we can just remove this current node. And here we can do current node value. And here as well. Okay, so it's -1. -1. So we put, we put 1, we put 2, then we get 1, then we put 3. So we should remove 1. We get, okay, so we put, then we get. So in get we Yeah, we should remove and then put. Okay, so here we see the problem. So some problem we see here that we return 2, but it should be -1 because 2 should be removed. So when we get this one, we take this one, then we remove our current node 1. In this case, the previous for 1 would be null, and next would be 2. So next previous, it's become like 2 becomes yes. And I think when we remove, we also should update our tail, right? We should do like we should do like this: if else, if node equal to tail, we should update our tail. We should say that tail is equal to tail next. Let's submit. Okay, we have a problem here. It's -1, but it should be 6. It's interesting. Can we analyze approach code style? Okay, current hash table, double linked suggestion. Key idea: combine hash map and double linked list to achieve. Yeah, so it's actually it's our approach. Code style, good. Suggestion: improve formatting and separate logic blocks. Avoid call input inside get to prevent redundancy. Okay. So what does it mean here? So yeah, we can actually update our put. So here we can remove our node for sure. Then instead of put, we can do, yes, we already have tail and head, I believe, input. What we can do, we can yeah, we already have this node, right? We already have this node, and this node we can update this node. So for example, we can, instead of put, we can do a C node. So first of all, head next would be equal to C node, and C node next would be equal to null, and C node previous would be equal to head. Then we should update head with our C node, and also we should map put I don't know, C node, like put key and C node value. And here, yeah. Map put C node. Can we run This test case. Yeah, I think it's the same actually what we have. So idea. So I do not expect that it will be something different here. All right, so we already running for 30 minutes. So I believe we can stop here. But I believe is that we almost solved this question. So I need just to verify by myself and we'll see. Thank you.